Yeah, hi. Good evening, everyone. So, welcome to the revision session 2 for end term exam. Okay, so today we have second revision session, and we will discuss from week 7 to week 9 content. Okay, and we will also discuss the questions in mock, which actually related to the week 7 to week 9. Okay, so we will start from the week 7. Before starting the session, if anyone have any query, I hope the in first revision session till week 6 content is covered. Can anyone confirm?
Yes, sir.
Yes, sir.
Okay, fine. Thanks. Okay, so any query before starting the session? Any specific query? Okay, so I'm opening the week 7 content, and first we will revise the content. Okay, after that we will discuss the questions from the mock. So let me share my screen first. Uh, okay. So I have created this summarized notes actually, and I've also shared the link in that calendar events. Maybe you all have this links of these documents. So if not, and then I'll share again in the today session. Okay, the drive link. So where we have notes for the 8 weeks, and 3 weeks are still remaining. Okay, so week 7 basically what contents are there. So we have two topics to discuss in week 7. First is array, and second is strings. Okay, and also we have also discussed the pointer arithmetic little bit in week 7. So we will start with the array. So what is the array actually, and how we declare the array, and what is the purpose of the array. Okay, so that you should clearly know what is the purpose of array. Okay, and what are the properties or what are the constraints of the array. So that things are actually important for the interim exams. So basically, array, first thing, definition should be clear. Okay, so array is a collection of items, and these items should be the similar type. Okay, suppose before introducing the array, where if we need to store some data in our program, so we generally use the variables. But suppose if we want to store the multiple data of the same type, okay, so then there is a problem with to create single variable for each data. Suppose if we have 100 data with the same data types. Okay, suppose we want to store the marks of the students, and we have 100 students. So it is not very easy to create 100 separate variable. So what we can do, we can store all the 100 similar type of elements inside the this array data structure basically. And this array data structure provide this facility, and we can store the all similar type of data in the continuous memory locations. And no need to store the address of each memory locations, because all these memory locations are continuously. Okay, suppose the first element is stored at the address 100. So that means second element, suppose we are storing integer element, second element will be stored at 101 address. Okay, 104, sorry. So after adding 4 byte for the integer, then we can get the second element address. The next elements will also store in the consecutive memory locations. So that means third element we can get after adding the 8 byte in the first address of the array. So in that way we can calculate. So during the processing or during the traversing inside the array, generally first what happen, first we calculate the address of the elements. Okay, so by the so we generally use uh, some one representation or notation, we can see that indexing. So that is the, we can directly use this indexing to access any element in the array. But internally what happened, the address is actually calculated from the base address, first element address. Okay, so we are not storing the address of each element in the array, we are only storing the address of the first element. After that, for another elements we are calculating, so that compiler is actually calculating the address internally, and we can access the element which is stored at any location in the continuous memory location. Okay, So first thing, array is a collection of items of same data types, okay, and it is stored in the continuous memory locations. And we, what is the, how we can declare the array? So this is the syntax you can see. Yeah. Okay. So first thing, we need to write this data type. Okay. So what type of elements we want to store inside the array? So that we have to mention here first. After space, we have to mention the name of the array, and then we have to declare the size. Okay. Well, how many elements we want to store? Okay. So this is the way to declare the array before using the array. And we can declare any type of array, so like integer, float, character. So we can create the array for any data type. And then size, array name is the identifier, and size just indicate the number of elements in the which we will store inside the array. So we can assign maximum size. So what is the maximum possible size we can store? But we can use only the lesser size, lesser number of elements which we have declared inside the size. Okay. Suppose we have declared the size like 100, but we later we can only use the 10 location or 20 location like this. Okay. So this is the first thing, how we can declare the array and what is the meaning of this syntax. Passing array into the function. So most of the time after week 5 we are creating the function in the all problems. Okay. So when we are creating the functions, so how we can pass the array inside the function? So what is the syntax basically we used for? So first thing, when we are passing the array inside the function, so that means what we are passing actually, we are not passing the complete array, we are just passing the address of first element. Okay, so basically we are passing the address of the array of the first element. So that means by size. So these two types of representation is given in this document. So void function name, data type. So we at the time of declaration of function, we have to define that what type of that parameter we are getting actually inside the function. So data type we have to define. So what type of array actually we are passing. So we have to declare that type of array inside the function as a argument. Okay. So data type and then array name, we can give any array name here, and we will just use this empty bracket and integer size. Okay. So here we are just declaring the name. So this is actually a pointer now. Okay. This we will use as a pointer, and we will pass the address of first element in the function. So that address will store inside this array name. So this will also work as a pointer. That means it will store the address of the first element. After that, we can access all the element by calculating the address in the continuous manner. And sometimes we also define the size, that integer size. So how many elements we have in the array. Okay. So if you are passing the array inside the function, so we generally pass the size also, because sometimes most of the time we declare the size as maximum as possible, but we use less number of elements inside that. So we generally pass this value size. So how many elements we have inside the array which we are passing inside the function, so that we declared. Okay. And another thing is we only pass the array. Later we can just find out the length. We can just check the length of the array by just that reading the array. Okay. So this is the code which is given. You can just understand the both representation here. So here we have two function, that sum array by size. Okay. So first thing we will look the main function. Okay. So this is the one array we have declared. Okay. And what happened, no need to mention the size always. So that size will automatically assign if we just initialize the elements at the time of declaration of the array. Okay. So here int number, that we are writing this empty brackets, and we are also initializing the elements inside this array. So these 5 elements will store inside this number array. Okay. And later we can find out that what is the size of this array. So how we can find out this? So we can simply check size of numbers. So what is the size of this number array? Because we have not given the size. So how we can identify that what is the array size actually? So because we have initialized the 5 elements here, so that 5 elements is actually stored. and each element is a integer type. So that means size of array you will get 4 into 5, 20 bytes. Okay, so this 20 bytes. After that, size of number 0. So that number 0 is means first element size. So that the elements which actually have at this first index, what is the size of this? So this is 4. So we can get the size. So what is the total size of these numbers? So that we will get 20 bytes, and after that size of each elements. So 20 by 4, we will get the 5 size. Okay, so we can calculate the size of array if size is not mentioned in at the time of initialization. So in this way we are getting the size dynamically. And other thing is that we are just getting the sum of these elements by calling the function. So here you can see that we are just declaring int total sum, and we are calling the another function sum array by size, and we are passing the array here. And this is basically a name of the array, and this is simply representing the address of first element. Okay, here we can also write like this now, that percentile, that end symbol and number and 0. We can also pass this type of. Okay, so that means when we are writing this number, this inside the bracket 0, so that means we are just pointing to the element, and when we are writing this end symbol, so it will return the address. And if you are writing only the variable names, array name, numbers, so this is also representing the address of first element. Okay, so that address is passing, and array size we are passing. Okay, so this is the address, and this is the size. So this is 5. Now we are passing this function, this details in the function. So this function is now reading. So you can see this ARR. So we have changed the name here. So now what address actually we have passed, that address will be stored inside this ARR, and size we will get 5. Okay, so that means this size variable is now reading 5, and this ARR contain the address of the first element of the array numbers. Now later we can use that information inside the program. So we are simply assigning initialize one variable sum, and we are reading all the elements by the indexing simply. Okay, and later we are just returning the sum value of the all elements of the array, and because of that we have declared the return type of this function integer. Okay, so this function will return the value inside the total sum, and that we are printing here. Okay, other thing is this char names. Here we are also doing something. So names, so you can see this is also a representation of array, but here we are storing the string. So we will discuss the string separately after this. So string is also stored as a array, where the each character is actually stored at one location. Okay, so names, and when we are just assigning initializing this string into the array, so that names array will create, and character array with null terminators. Okay, so how many characters we have inside this ALICE 5? Okay, but one more additional character will add after this E, that is actually null terminator. So that is actually identification of the end of the strings. Okay, so that this is also a array, and this names contain the address of first character A, and you can see we are just calling this function min value equal to find min. So this function here we are passing the array only without the size, but later what we can do, we can identify the end of the array by just this character. This is called as a null character. Okay, so we can run the loop I equal to 1. Okay, so we are setting min equal to first element, and after that we are just traversing the first index element to last index. Okay, so we will repeat this for loop till our ARRI does not equal to null character. Okay, so we will read the element, and once we will get this null terminator value, then we will stop the process. So elements which are coming before this, that will actually used for the process inside this. Okay, but you can see we are passing the strings, and we are performing this minimum things. Okay, we are finding out the minimum. So what happening actually here, the ASCII value is comparing for the each character. Okay, so when we are just comparing the character, so that means ASCII value of the each character is actually comparing, and based on that the value will return minimum value. Okay, so this is the way to just create an array and pass the array inside the function, and we can also pass the string array. And so this is called as a compile time initialization. So we have initialized the element at the compile time. Okay, so we have at the inside the code actually we initialize the element, but we can also read the elements at the runtime. Okay, so runtime, we have already mentioned, we already seen the code in the programming assignment questions. So how we can read the elements for the array. So we can simply run a loop, and after that we can just use the scanf symbol and we can pass the value by just the indexing of the array. So we will check if any example is given here. So this is simple process how we can read the printing the elements. So if you see the elements, so like this, so we will run the loop like this. Okay, so after that we will simply write scanf and percentile d, and we will pass the array arr and symbol and I, like this. Okay, and here we will write percentile d comma scanf, like this. Okay, so scanf percentile d and then comma and symbol arr and brackets inside I. So we will read the input and we will pass the input at the index I. So I we will pass like this, so I equal to 0 to I is less than size. So same way we can print also. So we will use the same similar type of loop, but we will use the print statement. The next thing is pointer arithmetic. So what is pointer arithmetic? So this is also related to the array thing. So we can how we can pass the array. We are passing the address of the first element, or we can also pass the address. Okay, pointer value. So here arr is also a actually contain the address, but we can separately create the address, create the pointer. So here you can see this is a pointer. Okay, int asterisk ptr. So this ptr is actually a pointer of the type of element integer, and that pointer is actually containing the address of integer type of elements. And when we are passing arr, we are assigning arr. So that means element address of first element that will be assigned to the ptr pointer, points to the first element. And now increment and decrement. So what type of arithmetic operation we can perform with the pointer? Okay, so that is actually called as a pointer arithmetic. So simply increment and decrement operation. So when we so in simple variable, when we write like a equal to 10 and we write a plus plus, okay, and suppose this is an integer. So what happened actually? So this a plus plus means a equal to a plus 1. Okay, so the value of a is incremented by the 1. But here it is not happen. So because we are performing this operation with the pointer, okay, and what type of pointer actually we are using? Integer type of pointer. So that means when we are writing this ptr plus plus, so suppose address of the first element is like 1000. Okay, this is the byte number. And when we are writing the ptr plus plus, so what happened? This ptr value will be updated like this. So ptr equal to ptr plus what is the size of one element? What is the size of one element? Integer element basically. Okay, so this pointer is type of integer. So that size of integer, that value will be incremented inside of this ptr. So that means when we are writing ptr plus plus, so it will move to the next element 20. Okay, so that ptr is containing the address of this 10 first element. When we are writing ptr plus plus, so that 4 byte will be added into this and it will become 1004. So that is this is the address of the second element in the array. So when we are just writing this ptr plus plus, so now it will move to the second element address. So 4 byte is actually adding, not 1. Okay, so same way decrement. So if we are just performing ptr minus minus, so that means 4 value will be reduced. If we are using character pointer, so then 1 value will be increment. Same for the decrement, 1 value will be decrement. Okay, so based on the type, what type we are using, that the size of that type value actually will be increment or decrement. So this is the first operation, increment and decrement operation with the pointer. And second operation, addition and subtraction. Okay, so this is also similar. So here when we are adding this ptr so this ptr plus plus means, so ptr equal to ptr plus 1, but this 1 is actually representing a one element size. Okay, but we can also write like n. So when we are writing ptr equal to ptr plus n, okay, and suppose n equal to 5, so that means 5 value is passing, but 5 into 4, that value will be add into the ptr address. Okay, if this ptr is a type of integer, so we can add and subtract any value, but that is actually a number of elements, how number of elements we are moving to the right or moving to the left, set the array. Okay, so if we are adding, suppose in this example you can see, uh, or in the previous example we can also see, suppose we ptr contain the address of first element, and we are writing ptr equal to ptr plus 3, so that means we will directly move to the this fourth element. Okay, so in this way we can directly add the value inside the pointer, but that value is actually representing a number of elements. Okay, that in that way that addition will happen. So here this example is given, so that ptr plus n, ptr minus n we are performing. So what we are doing in the previous example, we are converting that pointer into a character pointer. Okay, now that means this character pointer cptr is actually a pointer for the characters. Okay, each character, and after that we are adding this cptr equal to cptr plus 2, so moves 2 bytes ahead, assuming character is a 1 byte. So you know that character takes 1 byte, so if we are adding 2 and suppose cptr is contain 1000 address, so see that after performing this operation, so this cptr, that value will be updated by the 2 1002. Okay, because here the pointer character it is taking only 1 byte, so because of that we are adding 2. If it is a integer, then it will take 2 into 4, like this. Okay, next thing is array indexing using pointer. So we can also performing in that indexing operation. So how in general we access the array by this indexing, but we can also access the array elements using this pointer address and by this arithmetic operation, the pointer arithmetic operation. Okay, so how we can do this, so suppose this is the array and we have just assigned the first element address inside the ptr, and we want to read the value by this address without indexing. So what we can do, we can simply write, suppose we want to add access the third element of the array, so what we have to do, we have to simply add ptr plus 2. Okay, so this is the address updation, so that means we are adding the 2 element size inside the address, in the address of ptr. After that we are just dereferencing it. Okay, so that means this asterisk is represent what value is actually stored at that address, so that value will return. Okay, so when we are writing this asterisk and bracket ptr plus 2, so that ptr plus 2 is now pointing to this element, and this asterisk will dereference this address and will return a value, not address. Okay, so in that way we can directly read the value using the address without indexing operation in the array. Okay, so we can also run the loop. Similarly, we can access all the elements, and inside the for loop we can simply pass the value I here, and we will simply read I equal to 0, then first element, then I equal to 1, that means second element. So we will just pass a I value inside the for loop, and our each element will access without the indexing. So we can also access the element using the in that pointer arithmetic. Another thing is pointer dereference. So pointer dereference, that means, sorry, pointer difference. Pointer difference, so we can also perform this difference of operation, subtraction operation from one pointer to another pointers, and in that way we will get the number of elements. Okay, suppose we have the address of this fourth element and we have the address of the first element. So the address, suppose the address of first element is 1000. Okay, this is for 10, and fourth element will be, so 4, 8 and 12, so that means the 1012, this address will be for 40. Okay, and suppose this is ptr1 and this is ptr2, and now we perform the subtraction operation. So ptr2 minus ptr1. So what it will return? So it will not return 12 here. Okay, so this operation is actually performing in the terms of number of elements. So this will not return 12, this will return 3. So how many elements actually we are how many element difference we have in these two addresses? So that is actually so in that way you can also calculate like this. So total difference is 12, but each element size is 4. So that means this 3 value will be returned by this operation, subtract operation. Okay, so if you are using character pointer, so that means you will get 12, because the here this each element size is 1. So in this way we can also perform this difference operation. And another is comparison, pointer comparison. So here comparison operation we can also perform. So in this manner we will get this value. So ptr1 is less than ptr2. Okay, so here actually we are comparing the address, and this address will return like this. So if ptr1 value is smaller than the ptr2, so here not value, this is the address actually. So comparison operation is performed with the address, so that ptr1 comes before ptr2 in memory. Okay, so that things we can identify, so which address is actually greater. So that comparison operation we can perform like this, less than or equal to. We can compare the two pointer if both contain the same address. We can compare this. Okay, so that this operation is basically happen with the address, not the value. Here we are not comparing the value, we are comparing the address. But the remaining this subtraction or addition operation is actually happen with the reference of the number of elements, like this. Okay, so this is called okay, someone is raised the hand, so you can simply open your mic and you can ask.
There is no option to add to pointer addresses in C language.
Sorry, there is no option to
Add two pointer addresses in C language.
there is no operation to add to pointer. That
Okay.
addition, this is no way, we no meaning of the addition actually. We can add the value, so that value we have already discussed here. This type of operation we can perform. Okay, but we cannot add two pointer. Okay, so here when we are adding two, so this is actually a number of elements we are adding, and that the size of these number of elements will be added inside the pointer. But if suppose we have two different address in two pointers, so we cannot add. Okay, so these operations are actually called as a pointer arithmetic. So that means what type of arithmetic operation we can perform with the pointer. So this basic understanding you should have. Okay, so just you can just explore this by just running all these codes and check. After that, next is string in C. Okay, so how we can just represent the string in C? So in another language like Python, this is very easy to store this strings, but here string is actually in that Python also we have the different data types like str, but here we don't have any str type of data type. We have only char. Okay, char that contains only single character. Okay, but then how we can store the string that is a combination of the multiple characters? So we have to actually use array here to store the uh, string, that is the collection of the characters. So in this way we use this array again for the to store the strings. And string in C are represented as array of character terminated by a null character. So, okay, so this is actually a representation of the end of the strings. If we are storing the string inside the array, so this is the last value which will store inside the array. That is actually called as a null character. Okay, so C does not have any built-in data types. So now here we can see this some example here. So how we can initialize the string. So method one, using character array. What we can do, we can just create an array, str array, and we no need to define size. You can also declare the size here. But in this way, you can also simply assign the strings. Okay, so that value will be that strings will be assigned, and it will create an array actually. and each character will store at one index position. Okay, so H will store at 0 index, E will store at the 1 index, like this. One more point actually, that indexing thing. So indexing is start always from the 0 index in the array. So that is also important point. And method 2, using pointer to character array. So here what we can do, we can just assign this pointer. Okay, so we are not declaring the array, but this will work like as an array. So here we will declare like this pointer. Okay, and then we will assign the value. So both way we can allocate. So this pointer is basically a character pointer, and inside also the array will create, and each character will store like this: H, E, that L. But we have created the pointer for this, not the array. And this pointer will store the address of the first character. Here this array basically, the str1 will store the address of the first character. So both way we can store the that strings inside the array. Here we are just using the array term. Here we are using the pointer of array. Okay, so using pointer to character array. So array will create, but we are using the pointer to access that. If you print both, so you will get the same answer for those. Okay. And what are the operation we can perform with the scan that strings? So how we can read the strings in the input, how we can print the strings in the output. So here we have this scanf. So this is a normal reading operation, scanf, and we can use the specifier %s here. And this, what is the problem of this %s and scanf is, it will stop actually, it stop reading at the first white space character encountered. Suppose we pass the input like hello space world. Okay, and we have written this scanf like this. So scanf like this. Okay, and we are passing this hello world in the input. So it will read the character from first, and first it will this white space actually is coming, so it will stop. Okay, and it will not read the remaining characters which are coming after this space. So only hello will be read from the input, and after this space no character will be read. So if you are passing this hello world to this function, so you will only get hello stored inside this str. Okay, so this is the problem with scanf operation to read the strings. So we have another function that f get s, and in this manner we can read the complete line. So if you have a space, so it will read the complete line until the new line character actually occurred. So if you have complete big line, so that will be read by this function. But in later, if any point, if you are getting this new line character, so that at that point this will that reading will stop. Okay, so how we can write this code? So first we have to declare the array to store, and after that we have to write this function. So f get s. First here we have to pass 3 argument, and this first argument is actually a variable where we want to store the string, and we have to also pass the buffer size. Okay, so what is the maximum size we have to store? So that is actually 100. So that many characters actually will read here. So this is the maximum possibility. Okay, and this is the stdin. So this is the operation for standard input. So this will also work similar to the scanf, that is also a standard input. Here the complete line will be a read, and it will store inside this str. Okay, and then you can print that string by the same print function, printf function, simple using this %s. The complete string will print. And output, you can also use this printf function. Function is used to print formatted output. So this is formatted output. You can pass, you can add another string also inside the string. So like here you can see we are just storing this hello world, and after that when we are printing, so we are also adding the another strings inside this. Okay, and here we are actually printing the hello world. So we can concatenate the another part of this. So that printf is actually used to print in the format, the format is specified formatted output. Okay, so we can pass the
Hello,
value of
sir.
the. Yeah.
Uh, I had a doubt when you initialized constant character value. Can you just go back 2 slides, 3 slides before?
Hmm. Which
Little bit up, sir.
this?
Yeah, right there.
Okay.
Actually, what I understand now is that we are initializing actually a string one in 2 ways.
Hmm.
In first statement, we are creating a string one array
Hmm.
and initializing hello world in it.
Yes.
And in
Yes.
second, in second, things are different. Hello world, the first character of that string, address of that gets initialized in the string to pointer. Am
Hmm.
I correct?
Yeah. So
So,
actually, haha. Yeah. Go ahead.
yeah, but but has a little bit different. Hello world, as we write any character, a set of characters inside those two double commas, we treat it as a constant character, which is
Hmm.
stored in memory as a and treated as a constant character. It has
Yes.
its own address. So first, we initialize. We just create a constant character array of hello world, and we
Hmm.
copy its data into a string one array. Uh, and second one, it's already there, but we just get the address into a string two. But can we change the value in second
No, we
method?
cannot change
We
this. We cannot change this.
Okay,
Second one
okay.
we cannot change, but first one we can change. Okay, so this is
Means it's
this is
read
an
only in second method.
so this is actually a constant type of strings, and this is stored in the array, but we are storing the address of the first location like this. Okay,
And
so
what is the scope of this constant string, sir? Does it only gets free space? I mean, freed up from the memory when program ends, or is there any specific
okay, so
scoping regarding?
okay, let's just discuss this in the replit. 1 second. Okay, so what we are doing, so we are writing this care str1, and we are writing this hello world first. Okay, so this is the first, and another is scare and pointer str2 equal to same hello world. Okay, and after that we are printing both. So print printf and percentile s that and that str. Okay, so 1 second. Let's run this. This 1 second. We have to. This replit actually have some issue now. And why the output is not coming? Okay, so let's say slash n. Okay, so we are getting the same output for the both, but let's try to read or update the things. Okay, so be able to read the value str1 and like 1, okay, or 0 equal to, so like r. So is it working or not? Str0 is not updating. Str2. Oh, 1 second. This is 2. It is not updating. So str2 we are not able to do anything here. So okay, you can see when we are performing this operation str2 that is not updating. Or if suppose if we write like this, yeah, this is actually a pointer. So we cannot update the value by the
And
pointer.
it seems to have a global scope that when program ends, then only the constant character will be freed up from memory.
Yes, yes. Uh, and but that str1 actually this is not updating. E. So R is now removed. H E. Character is removed, but it is not. Okay, suppose if I do this, sun mark.
Should not we use a single
We cannot
inverted
update.
comma,
Yeah.
sir?
Hmm.
Should not we use single
Okay.
inverted
Yeah.
comma there?
Correct. 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 And Python actually we can use both representation. Yeah, it is updating. Okay. So yeah, you can see we are able to update this first way. If let's remove this, you can see now this become capital A. Okay, so we are able to update this first string, but we cannot update this str2 like this.
Yes, yes, got it.
Okay, this is actually works as a constant. But we can store these strings and we can access the character like this, so we can perform the reading type of operation, but we cannot update the part of that strings. We can update the complete value but not the part. Okay, so and another thing is okay, so scanf, that fcat as we have discussed. So now the printf, so this is format type of printing. We can also add the new strings. We can pass the variable value inside the strings, so like this. But using puts as we can completely that print the strings directly. Okay, so we can just pass the variable inside this put as, so that strings will print. But here we cannot just using this format specific things, formatted strings. Okay, so some difference we have. So like this, both are used for the string output, but put is automatically appends in new line character, making it simpler to use for printing string. Okay, so when we are performing this put s, so this complete strings will print, and after printing this strings, automatically this new line character will add. So next strings will be print in the next line. So we can direct, if we want to print the multiple lines, so you can use directly this put s, and the each line will be printed in the separate line by adding, by using this uh, new line character. So, and another thing is some basic operation on the strings is actually strlen. So we have this two types of things. First is size. Okay, another is strlen. So if we are declaring the size, so suppose we have this type of code, hello, we have declared this. So length of the string, what is the length of the string is here. Okay, so we will use this strlen function. So what length will come, and what is the size of this. Okay, so both are actually two different things. So let's just okay, once pointer. Let's that also test this. So size of, this is also important, size of and str len. Okay, but this is strlen. So here you can see size we are getting 12, and but length we are getting this 11. So size, so this is the total length actually. So lower one value, so this print strlen, it is representing the number of character which we have. So we have the character total 11. So if you can count this, so you have total 11 characters inside the strings which we have initialized. But what is the size? Size we have 12 because one new line, that null actually character is actually adding after this d. So it is returning the size including the null character. So because of that, we are getting two different things. So size is now 12 including the null character, but length is actually 11 without including the null character. So these two function return two different value. So this is the first function we generally use to find out the length of the strings or length of the array. And str copy, so this is the function to copy the string from one pointer to another pointer, one array to another array, like this. Okay, so here you can see we have created one array src and we have initialized the value. Another array we have created, so we cannot copy the strings like this. So dest equal to src, we cannot copy in this manner. So we have to use this function to copy the one string to the another string array. So we can use this function str copy, and this the variable where we want to use is to that copy the strings, and where from we are copying the string, that this is the variable as a second argument src. So after calling this function, so this src content will copy inside the dest array. So in this way you can copy the strings. Then strcat, how you can concatenate two strings. So you can use this operation. So in this way you can declare like two strings. So this is the first string, this is second string, hello world, and then you can concatenate this. So str1 and str2, both string will be combined into the str1. Okay, so that means str2 value, this value will be add concatenate into the str1 variable. Okay, so now you can just print the str1 and you will get the concatenate value. So strcat is actually a function to concatenate. Next is this strcmp function. So this cmp function is basically compare the strings. Are the both strings are similar or not? So if both strings are similar, then this function is actually returns 0. Okay, so if you are getting 0, then that means both strings are same. Otherwise strings are not same. So if you want to at any point, if you want to compare two strings, then you can use this strcmp function to compare the strings. Next is strchr. So find the first character of the character in a strings. So in this way, you have to use here that pointer subtractions. So this is the basic function. Suppose this is the strings we have hello. Now when we will call this uh, strchr function, and we will pass the strings. Okay, and we will also pass the character which we want. So for this character actually we want to find out the first occurrence. Where is actually the first occurrence we have for this character inside the strings? So it will return a address. So this it will return the address of the location of this first L. Okay, so HELLO. So the first L is occurring at the third position. So what is the address of this third position? It will return by this function, and that we will store in some place. After that we can find out that so what is the character position, that we can find out by the subtraction operation. So ptr is the address of this first L, and this str contain the address of the first character. So suppose this is like 1003 and this is 1000, like, okay. So we are subtracting this, so we will get 3, because here the size of each character is 1. So we will get this 3. So that we can conclude that at third position we have the first L character. Okay, so in this way you can identify that where the character occurs first time in the strings. And another function we have strtok, and this tokens, actually it is called as a token. This actually split the strings into the token based on some delimiter value. So if we can assign the delimiters, so where from we want to just split the array, split this strings. So here you can see this is the strings, and we can pass the set of delimiters. So this is the set of delimiters, that comma, this marks and a dot. So we can pass this as a strings, and space also. Okay, so second here this is a space. So once this type of character is found, so this comma is there, space is there, this exclamation is there, and dot is there. So this complete string will be split from these characters, and each characters will be read inside the token. So this is actually a complete set of this code. So first things we will just write this character string token. So this is the pointer, and this will return the address of the delimiter. So str delimiter, we are passing this is complete strings and delim, this complete set of the delimiter. And after that we will run a loop. So while our token does not equal to none, so this condition we will write. So our token is does not equal to run, we will repeat this process, and we will get the token. So first this hello value will become inside the token, that value will be print. Okay, after that the next iteration, this word value will become inside the token, that will be print. So in this way all word will actually come inside the token, and all will print. After that we will get the null. Okay, at this time this value will terminate. So in this manner, so this is a complete set. You have to write this syntax first, and then you have to write this complete while loop, and you can split the strings into the like word here. Okay, so separate word by separated by the delimiters mentioned. So this is
Didn't quite get it, sir, clearly.
hmm? Sorry.
Didn't quite get it, sir, clearly, how it works actually.
So here actually what things is doing. So this is first thing. This is actually a pointer, and we are dividing this as the first time. Okay, and we are first time we will pass the complete string and the set of delimiters. So we will get the token address of the first word here. So like this hello. And when we are just looking this checking this condition, token does not equal to null. Okay, so that means token is contain the address of first word here. So in this first operation actually, uh, we will get the address of first character, and this will split. Actually this complete strings will be split, and we will get the separate word, this hello world, this is a test. But inside the token we will get the address of this first address of this h. Okay, and this is the complete strings. Okay, after that we are getting, so this comma will actually replaced by the that null character. Okay.
Okay, now I got it. I was confused that how will we identify where it ends.
Yeah. So after, so that actually every delimiter will be replaced by the null characters, and this token will store the address of first character of this. So that will be print first. Then we will repeat this again. Okay. So that will start from the null character again, and we will pass this delimiter again. So next part will be read, and the next token will come. This like okay. So in this way, each word will be come inside the token, and it will print. Okay. So you can just explore this by just running this type of code and on some type of inputs, and you can check what value is coming inside the token like this. And this is str. So here we can find out the address of the substrings. So suppose if we find out the first occurrence of a substring within a strings. So here's, for example, this is hello world, this is word, this is a substrings. Okay. And we want to find out at what address actually this word is coming. In the previous, when we find out this character first occurrence, here we are finding out the substring first occurrence. So this word, when this word is actually occurred in the strings. So since this is also similar, so we are passing the str and we are also passing the substrings. So this function will return the address of this w. Okay, so what is the first character address of this w inside the substring, and where it is occurred in the main strings. That address will come inside the ptr, and after that we will simply subtract this ptr address minus the base address of the strings, and we will get the position where this is occurred. So these are some basic string function. There are many other function are also there, but these are very common which we generally used. Okay, so this is all about the strings. Now we will move to the beak 8. One second. Okay, so beak 8, where we are just discussing this user defined data types, and these user defined data types we are discussing only these some user defined data type structure, union, and enum. Okay, in this peak. And what is this structure? So we have discussed in the weekly live session. So structure is basically used. So now in array, actually we are storing the similar type of data. Okay, suppose we can store only integer type of data or maybe character type of data. But what happen if we want to store the records? Okay, where we need to store the multiple value in the group manner. Suppose we, if we want to store the students marks with students name with student course like this. Okay, so complete details of the students, like, so we want to store the student names, corresponding student course, corresponding student marks like this in the group manner. So here student name is actually a string, student course may also be a strings, but marks will be represented by the that integer or float. So the group data basically may contain the different data types value. Okay, similar type for the employee. So what is the employee id, what is the employee name, what is the employee salary, like this type of information. Okay, so maybe id will be represented by integer value, and the name will be represented by the strings, and marks will be represented by the float value. Sorry, salary will be represented by the float value. So different types of data we want to store in group manner. Okay, so that means for particular person, what is the related information of that person we will store inside the one group. Okay, so here how we can perform this type of how we can store this type of data in our program. Okay, so like we have the student name, so st name. Okay, corresponding st course and st marks. So these fields we have. Now after that we want to store the record for this. So suppose first detail we have for name is Amit, and course is like that C, and marks is like 60. Okay, so this actually one complete information is referring to the one student. Okay, so this will be stored inside the one group of the memory. So if we later if we want to read this information, so that information we can read inside this one group. So what is the score, what is the marks for Amit, So we can simply search the name and corresponding we can return the marks. So this type of grouped information we want to store, and C actually provide this grouped structure. Uh, this is called as a structure. Okay. So a structure in C is a user defined data type. So here this type of structure we can define that allow grouping together variables of a different data types under one name. Okay, so we will store different types of variables under the one name of the structure. So what is the syntax of this? We can just simply write, we can write like this: struct and structure name. Okay, this structure name we can give any name according to our that requirement. And this is open bracket, and this end bracket with this colon, and inside this we can declare the any number of variables with different data types. Okay, so data type, and this is simply a variable declaration. So here data type may be the different. So first, like this, strings or array, that integer, float, double, any types of value we can store inside this. So this is the syntax for the structure. Now example, if you can understand here, so we want to store the student information, and each student have three fields: name, age, and marks. Okay, so that means for each student we want to store these three information. So name is a string, age is a integer, marks is a float. And in program you can see how we can create the memory location for this. So we what we can do, we can create a variable for the where the data type is struct student. Okay, so this is the struct student, and we want to declare a variable for this structure. So we have to write this struct student as a data type before the variable. Okay, so this is actually a data type for this s1. Now what we can do, we can simply read the value for each field of this s1. So now this s1 is actually contain three fields: name, and this age, and this marks. Okay, so for three variables we have given this name s1. Now we can store the value for each field for this s1. And name we can assign any value, age we can assign any value, marks we can assign. So you can see we are just reading all the value. And if we are declaring this, so how we can access the field? So this is also important point. So if we have declared the structure variable, then how we can access the field of that structure? So that we can access by the dot operator. Okay, so this dot operator you can see s1, this is the structure variable, dot field name. What is the field name for this? So if so, that means the one memory block will be created for this. So what is the requirement, what is the size requirement for name? That will be allocated for name, another for age, another for marks. Okay, so here you can see name this 50 characters, so 50 bytes will be assigned here. Okay, age will take 4 byte, and marks, this is a float, so it will also take that 4 byte. Okay, so in this way the memory allocation will also be happen separately for each field. Okay, but this complete block will be actually allocated for this s1 variable. So, and later we, after reading this element, we can also print the element by the same dot operator. So this dot operator is important because we can also create a pointer for this structure. So what we can do, we can also create the pointer. So like same struct student, this is the pointer data type, and stick p. Okay, we can declare the pointer for like this. Okay, and we can store the address of this structure, p equal to end s1. Suppose we have the address of a structure, then how you will access the field? Okay, then you have to write like this. So p, then dash, and greater than. Okay, like this. Okay, dot name. Then you cannot access the field by the dot operator. Then you have to use this symbol if you have address of the structure. Okay, p dash, this is looking like arrow. Okay, but this is a combination of two character, dash and greater than. Similar for p age. Okay, and p, then marks. Okay, So this, in this way, we can store the element and we can also return the element, print the element. Okay, and if you have the variable, then use the dot operator. If you have pointer, then use this arrow operator. Okay, so this is the way to for the representation of the structure. Similar type we have union data structure. A union in C is a user defined data types that allow storing different data types in the same memory location. So this is the actually difference. Here in the previous example structure, we are allocating the different memory location for each field. Okay, so 50 byte, 4 byte, 4 byte. Suppose we want to create the union, then what happened actually? Here, memory allocation is not allocated separately for each field of the union. So the syntax is very similar to the structure. So you can see we need to write only union and then union name. After that, we can declare the variable names of different data types also. But here the memory allocation is happen. One memory location is actually allocate for each variable. And suppose this first variable is type of integer, so this is taking 4 byte. Okay, and second type is character 1 byte, and another type variable is double, so that is taking 8 byte. Okay, so how many memory will be allocated for the overall this union? So what is the largest data types we have for any variable, that is actually will be allocated? So 8 bytes, suppose we have three variable and one variable is actually double, so that is actually taking 8 bytes. So 8 byte is only allocated for this complete union. So that memory 8 byte will be shared by each. Okay, so most of the time union is actually used if you want to store one value at a time for the variable which you have defined, not the all variable. Okay, so here at a time, if you want to store only maybe double value or maybe that integer value or maybe the character value, but so at this time this one memory block will be shared for each. So you can store this integer value inside this, that will also store. You can store character also in this the same location, and you can also store maximum this double value. Okay, so at a time one value if you are storing, that will work fine. So this is the difference in union and structure. So okay, so here one example is given. Suppose value you want to store. Okay, but value may be different. It may be a strings value, it may be a float value, it may be a integer value. So based on that, you have declared this union. So here strings value is the maximum size 20. This is a that is this is 4 and this is also 4. So that 20 byte actually will allocate for this complete union. Okay, the 20 byte will allocate. So all variable will share this memory location. Okay, at a time you can store any one variable value, so you will not get any problem. So you can see here we have declared this v int value is equal to 10. Okay, now we have changed this v float value equal to 3.14, and later we have assigned some strings. Okay, so this is the union. And what is the enum? Enum is actually a user defined data type to assign the name, that names to the integral constant. You can use some name, but some integer value will also be assigned for that name. This is for actually to easier to read and maintain the code. So no need to just always use the integer value and this type of representation. You can also assign some naming for your program, that is actually easier to read or understand. So the example is here. Yeah, you can ask if anyone is raising the hand. Someone is raised the hand. Okay, no. Okay, moving to the next one second. So here what we are doing actually, suppose this month. Okay, we want to store this month, and month have only these 12 types of different value, Jan to this December. Okay, but this is actually more readable if we are writing the Jan pair, instead of if we are writing 1 2 3 4 5 some value like that. Okay, so that is actually not directly just that give this information which month we are talking about. So what you can do, you can assign a some naming, and that namings will automatically assign, or you can also assign some integer value that will be used for this name inside the code. So enum month, defining the enum, you if you are defining one enum data type, and this is name is month. So for more reader forms, you can represent this gen. Okay, so this is the naming, and you can assign the value for this gen. So gen is the first month, so you can simply assign gen equal to 1. Okay, and when you assign the integer value for the first naming, so the remaining value will be assigned after this addition of this one. Okay, so that means by default feb will be assigned by 2, this will be assigned by 3, this will assign by 4. In this way all value will be assigned by like this 12. Okay, continuously from 1. Okay, so this is and later in the program at any point you can pass this name, but the value actually will be used. What value is assigned, that will be used. So here you can see if we are suppose assigning like this enum month equal to m1 m2, and when we are assigning m1 equal to feb, we are writing this feb month. Okay, month 2 equal to now November, and when we are printing this m1 and m2, so the corresponding value will be print. Okay, corresponding integer value will be print inside the code, not this feb or nov. Okay, so suppose we if you want to just write the switch statement, so you can use this, you can pass this uh, month name like this feb jan. Okay, but the inside the case that 1 and 2 value will be passed. So and what happens, suppose the some question may be asked. So I think some question is given in the mock question also. Suppose this gen 1 value is assigned, and here suppose here we just write like 4 for the mar. Okay, so let's I remove this first, then we'll discuss. Okay, suppose you are given like this gen equal to 1, and later here you are given like 6. Okay, so what is the value for this like AUG? What will be the value for AUG, and what is the value for MAR? Okay, so in this case, if you have initialize this value gen to 1 and APR to 6, then by default before 6 you will get the continuous sequence from this 1 till MAR. Okay, so that means by default this will be 2, this will become 3, but after the 6 increment will happen from the 6. Okay, so may will become 6 plus 1, not 3 plus 1 like this. Okay, so this will become 7, this will become 8, and continuously. Okay, so in this way by default the value is actually initialized. So you can also initialize by your own, but by default it will automatically initialize.
If we don't explicitly assign any value, then will it start from 0 or 1?
Yeah, it will start from 0. So let me quickly
Okay.
check this also. Let's now okay. 1 second. Okay, B C D A. Right, also. Okay, suppose if you want to print this piece, so print. First, we have to declare the variable for this. So enum a entirely comma that s1 value. Suppose okay, we will define the value. So S1 equal to C. So you can see 1. By default, we are getting initialized with 0. If we are not initializing with any value, so that it will start with the 0. Okay, so for C we are getting 1, then 2 in this way. Okay. So these are three topics which is discussed in the week that 8. Okay, so enum, and later some examples are given on this. So you can just check these notes and you can just read these examples. These are basically the codes, some problems and codes. So day of the week like this. Okay, and the next is week 9. That is we have discussed this dynamic memory allocation and two-dimensional array. Okay, so dynamic memory allocation is basically that memory allocation which we want to allocate at the runtime. When our program is actually running, at that time we want to allocate some memory. Okay, so that is called as a dynamic memory allocation. Otherwise, the memory allocation happens on the compile time. So suppose if we have initialized an array or any variable or any data type, that actually that memory is allocated at the compile time when our program actually compiles. But what happen if you want to allocate memory when our program is actually running? Okay, at that time we want to allocate. So we that concept is actually called dynamic memory allocation. So we generally use some function for this dynamic memory allocation. These are basic 4 function we used for this memory allocation. So first is actually malloc function. Okay, and malloc is actually allocate a single block of memory of a specified size in bytes, and it returns a void pointer, generic pointer that needs casting. Okay, so it if we are not assigning any data type here, okay, so this type casting we are not represented, so it will return a void type of pointer. So because of that, if you want to use this memory block for a specific purpose to store some data type of elements like integer or character, so that we have to use this typecasting after allocating this memory allocation. Okay, so what is the syntax for this? Syntax is basically this malloc. This is the main syntax for this malloc function, and malloc, and it takes one argument. Okay, and one argument we can pass as a expression also. So if you know the exact size, you can directly pass the size. If you don't know, if you know that how many elements you want to store and what is the type of element, then you can get the size of each element by this function size of. Okay, suppose you want to store the 5 integer elements, so you can simply write 5 into size of int. What is the size of int? Is actually 4. That will be multiplied by 5, and 20 byte actually will be passed as a one argument inside this function, and you will allocate this 20 byte memory block. Okay, so this is a one complete block. And what is the purpose to allocate this memory block? What type of element you want to store in this? So you have to use the typecasting here. So here you can see you have declared one pointer number, and the type of this pointer is integer. So you have to convert this address, which is actually a void type, to into a integer type pointer. Okay, so you have to use the typecasting for this int stick. So now this block address will be used as a integer pointer. You can simply get access the elements like the integer form. So first element you can store in the first 4 bytes. Okay, next 4 bytes you can store the second element like this. Okay, in this way you can use this as a array, like the array. You can also access the elements similar to the array by the indexing also. Okay, so in this example, okay, so this is the malloc function. Okay, this is allocated the memory, and now this is some expression we cast the return. Okay, this is discussed. Now this is the example, you can easily understand this. So first we have declared the pointer. We want to get the memory allocation for 5 elements. Now we are writing this. So ptr equal to int malloc size of int n. Okay, so n, what value we are passing here? 5. So that 20 bytes memory will be allocated, and we will use to that 20 bytes to store 5 element integer type. Okay, this is just a check if we are getting the successfully memory allocation or not. If this, that means if you are getting null address in this ptr, that means memory is not allocated. So you can prevent your code by checking this condition. If this condition is not true, that means memory is allocated to you. Then now you can use that memory for your purpose. You can store the elements like this. So here what you can see, you can simply access the locations similar to the array. Okay, you can simply use the I variable I equal to 0 to n and I plus plus, and you can simply using this square bracket, and you can pass like as index, and that will similarly will be accessed similar to the array by indexing. So that means ptr 0 is will be represent of the first address of the integer elements, ptr 1 will be represent to the second element address, like this. Okay, and later you can use this. So this memory is actually, when programming is running, you can just read this value and you can pass this value to the function. At that time this memory will be allocated. So this memory is allocating at the runtime, and you can, but after using this memory block, this is the good practice to just release this memory when your programming is completed. Okay, so this is the one another function in this group, free ptr. Okay, so if you have allocated some memory, then just that free also. Okay, so this is first function. Second function, we have the calloc. Calloc is also a similar to the malloc function, but it takes two argument first. Okay, this is the first difference. So we have to pass the n value. What? So this actually provides the block of the elements, not the complete one block. Okay, so how many elements we want to store? This is the first argument, and what is the size of each element? So this is the second argument. Okay, so after that, basically it total memory allocation is actually happens in the combined form, 20 into size of this, but that you will get the block of element, 20 block of 4 bytes, like this. Okay, and that are actually continuous. But another difference is that each block will be initialized with 0 value. This is that is not the case of malloc. Okay, so initialization is also happening at the time of memory allocation. So these are the two difference. So calloc takes two argument, and that allocate memory is set to 0, ensuring a clean slate for storing strings or another data. So these are two basic difference in the malloc and calloc. So same type you can use this memory allocation, and like I say malloc. So you can see we are writing the same type of typecasting we are using. Only the difference is two arguments. After that we will use the same way. So this is the only prevent your code, and this similar way like an array you can access the element and you can store the element, and later you can free. And next function is realloc. So realloc function is basically, suppose if you have allocate some memory blocks, but later you want to that allocate more memory blocks. Okay, that means you want to just extend your memory size. So here you can see first we have initialized, we have allocate 5 elements space by the malloc function, but later we can also update this space by the realloc function. So what we will do, we will use the same pointer number, and we will use this realloc, and the number we will pass. Okay, so it takes two argument, number, that means the previous memory allocation, and what is the new size. Okay, so 10 into size of each element. Previous was the 5 into. So 5 we have already, and but we want to now extend to the 10. So suppose if you have stored first 5 element. Okay, so suppose you have stored like this element 1 2 3 4 5. So 1 3 4 2 8, like this. Okay, there is a chance when you are using this realloc function, so maybe the complete memory block will be shifted to the new locations, but this data will be prevent during this extend. Okay, so suppose the address of this previous allocation was like 1000, and all elements are stored continuously, but later you just reallocate the memory, and you will get the allocation for 10 element. Okay, and the starting address is now 2000. So there is no guarantee that you will get the continuous memory locations after this. Okay, so maybe you will get the different memory locations, but these elements will be copied into this new location. So like 1, 3, 4, 2, 8, and the remaining 5 locations you will get continuously empty. Okay, then you can use for the data purpose. So this data will actually remain in the memory, and this will not lost, and you can extend your memory. And then final operation is free function. We have discussed this. So this is just a deallocate the memory. So after every allocation, after every use of this malloc and calloc and realloc, just free the memory once you have completed your task. Now next is 2D array. So two-dimensional array is basically to store the data of this type, like this matrix. So matrix is the best example to discuss for the 2D array. So sometimes we have to represent the two-dimensional data like matrix or image representation, or some example is mentioned, I think applications, if it is not mentioned. Okay, so this two-dimension type of data which is represented actually in two dimension, that we can store in 2D array. So where we have the like row and column combination to store, and you can see what is the syntax for this is data type array name, but now this time we are passing two different value in two brackets. So first is actually rows and second is actually columns. So rows is actually a group of memory which is represent one row. Okay, so row 0. Okay, so each rows actually contains some block that is actually called as the columns. Okay, so row 0, row 1, that is also contain the similar number of blocks, that is actually number of columns. Okay, so suppose we want to store like 3 into 4, this type of matrix representation we want to store. So 3 rows and 4 columns in each rows. So that means each rows actually contain 4 block like this. Okay, so this is now rows. So indexing is also start with 0 for rows and columns, 0, 1, 2, 3, and column also 0, 1, 2, 3. So this is now become a sorry 3, 4 by 4. So we will remove this. So this is 3 by 4 presentation. Okay, so 3 rows and 4 columns for each rows. So this type of data we can store in two-dimensional array by this representation. So here rows is actually number of rows in the array, and column, this column value is represent how many columns we want to store inside the array. Okay, so that type of array we can also create for each type of data. So like characters, float, integer, and this is the simple initialization. So you can see here we have just initializing this. Suppose we want to just perform this tic-tac-toe games. Okay, that board, empty board, and you can use this 2D character array to represent the board state. So here you can see we have created 3 by 3 array, 2D array, and each rows actually have this empty data. Okay, so by this single quote space, okay, blank space. So this will just create a 3 by 3 matrix, each have the empty location. Okay, so row 1, row 2, row 3. Then we can fill this like cross 0, 0, cross, like. Okay, so this is one example for the 2D array. And so this is the initialization at the compile time, and we can also perform this initialization at the runtime also. We can read the element at the runtime by the nested loop. So you can see we can also initialize the matrix at the compile time like this. So size, this is the size 3 by 4, and after inside the one curly braces we will just write the another curly braces. This is representing one row. Okay, this is representing second row, then third row, and each row actually have the 4 value that is representing columns for each row. Okay, so this is 0th row, and this is first index row, this is second index row, and for each row we have 0, 1, 2, 3. This is the columns. Okay, and how we can traverse the array? So we can use this two nested loop, for loop. First for loop for the to access the row, and inside this row, for each row, second loop is actually for the columns for each row. Okay, so for I equal to 0, that means we are accessing the zeroth row, and inside this we are accessing the each column for the zeroth row. So this will run by the nested for loop. So after reading the all columns for the first row, then our outer loop will increment it by 1. That means we'll move to the second row, and then again we will access. Okay. So in this nested loop, we can read the elements by the scanf, okay, a function, and we can also print. We can use the print statement to just print the elements of the 2D array. Okay, so what are the basic operation we can perform with this matrix type of 2D representation? So suppose sum of elements. We want to perform the sum of elements of this matrix. So we can simply use this nested list, and we can access the element, and we can add into the sum. So sum is initialized with 0. After that, we are traversing each element from the 2D array and adding into the sum. In this way, we can read finding maximum or minimum inside the 2D matrix. Okay, so for finding maximum or minimum, so you have to traverse all the elements in the array, and you have to compare this, then you will get the maximum or minimum. Okay, so real life example, image processing, games is also represented sometimes in 2D representation, matrix, data analysis, like this. So these are some examples. And how we can declare this 1D and 2D array using the dynamic memory allocation. So this is also one another. So we have already discussed one dimensional array. So using the malloc function, so you can see we have created one array pointer, ARR. This is not an array, okay? So this is just a pointer. And after that, we have just reading the size, and we have allocated the memory for that. And then we are using that memory allocation as an array. So this will similarly work as an array, and we can use indexing. We can store the element using the indexing. We can read the element using the indexing. So this is for one-dimensional array, simple. And 2D array we can also declare using this dynamic memory allocation. But here we have to create the pointer array. Okay. So basically, this is a pointer ARR. So this is a pointer, and this also contain an array where the each value is actually also a pointer. Okay, so this is also a pointer, and that actually points another memory block each. Okay, so that ARR is actually a pointer that contains some memory, that array. Okay, and where the each value of the array is also contain the address of the another array. So in this way, you will get the 2D array representation. So like this. So you have, this is the pointer for the rows, number of rows. Okay. So like this, R1, R2, R3, R4, R5, R6. Okay. So total 6 rows. And you have the name like array, and array is also a pointer which contain the address of the pointer array. Okay, now each pointer is actually contain one memory block like this. Okay, so now it will also become a two-dimensional array. So here you can see we are reading the number of rows and number of columns. Here we are creating the pointer array. Okay, so you can see we are using this pointer. We are also typecasting like as a pointer, and how many number of rows actually we have, and what is the size of each pointer. Okay, so this is actually a pointer. What is the size of each pointer? That memory block we are actually assigning for this. So how many rows we have? 6, and each have contain the pointer. So that means size of each pointer is 8. So that means 848 that bytes will be allocated. Okay, so this first allocation is actually for the number of rows, and second allocation we will allocate for the each rows. Okay, so you can see ARRI. This is also representing a pointer, and now we are allocating another memory block of integer. So that is memory block is allocated to one pointer for the first row. So in this way, we can allocate the memory block for each rows pointer. And later we can use this like as a 2D array. We can simply access the each element by simple two-dimensional array like I and j by two indexing. Okay, so in this way you can also declare at the runtime this 2D array. So yeah, this is the week 9. Now let's move to the mock question. So I hope the question till question 9 we have already discussed in the last session, and the 10th question is actually started with the array. Okay. So first question is, which of the following statement is a statement about array initialization in C is correct? First thing, this mock is actually a paper of the last term. Okay, so this is not a sample or practice questions. This is actually a paper of the previous terms, which is asked in the previous term as a final exam. So, so you can just assume that the same level of the questions in the final exam. So, which of the following statement about array initialization is C is correct? Okay. So we are just talking about the array. Now, array can only be initialized at a time of declaration. So this statement is not correct, because array can also be initialized at the time of runtime, not only the compile time or the declaration time. We can declare the array first, then later we can assign the elements. Okay. So this first statement is not true. Second statement we have, array can be initialized both at the time of declaration and later in the program. So yeah, this is correct. Array can only be initialized with integer value. So this is also not correct. We can also store character, float, any type of value. The index of the first element is an array is always 1. So this is also not correct, because indexing is start with 0. So here option B is correct for this. Okay. Now move to the 11th. So here 11th question. Okay, so this is the programming question. So let's just discuss the step by. Okay. So just okay, go step by step. So this is the first statement. We have the size of 8. Okay, so that means we can just write like this. So we have total 8 elements. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 7. Now array 0 is actually contains 1, and this is 2. Now we are running a loop from I equal to 2. So that means we are running from this second index till 7, till here. Okay. And what we are doing, so we are storing array I. That means we are storing the add value at this location. So what is the current value of I is 2. And we are adding the array of I minus 1 and array of I minus 2. What is the previous 2 value actually we are adding, and we are storing at this location. So this is similar to the Fibonacci series. Okay, so what we will do, we will just add the previous 2 value, previous 2 locations value, and we will store in this. So 2 plus 1 is 3. Now we will repeat this process, and I will be incremented by 1. So what is the previous 2 value is 2 and 3. This will store here 5. Then 5 plus 3 is 8.
Sir, it's multiplication.
Oh, okay, sorry. Yeah, so this is actually multiplication. Yeah, correct. So the previous 2 value multiplication is 2, and then it is 4. 2 into 2, 4. 4 into 2, 8. And 8 into 4, 32. 32 into 8. So 6, 24, and 25. 256. Okay, and next is 256 into 32. Okay, this is something. But in the question statement, the value is asked at array 6. So what is the value at this position? So this is actually 256. So that 256 should be the answer for this. Okay, so this is simple the traversing of the loop. Now move to the next. Consider the following C program. Okay. Yeah, we have already discussed this. So here we have declared this int main and char a of 10 equal to hello. So here, what is the size of array a? This is 10, but we have assigned a value HELLO in this.
15.
So here size of a will be 10, correct? And plus str len is actually represent as a number of characters which we have assigned initialized. Okay, so number of characters we have only 5. So 10 is the size and 5 is the length. So 10 plus 5, this 15 should be the answer for this. Okay. Okay. Next code is simple. This main is okay. Here this is a pointer. Okay, so we have just initialized this one pointer s equal to hello C programming this, and after that what we are doing, we are simply accessing the pointer s plus c. Okay, so we are updating this. We have created this new pointer s tick p, and we initialize this pointer with s plus 6. Okay, so s plus 6 is basically so that the value will be assigned after the adding of the address of first character of h, then plus 6, so that means after 6 character. Okay, so that means first value h e l l o total 5 and 1 space 6. So that means second strings will start, so this p pointer will start reading the strings from this place. Okay, so that part is actually stored inside this p pointer C programming. Okay, so initial 6 character is actually removed when we are assigning this new address to this. Now the Q is also contain the same string C programming. So now you can see both contain S and Q, or sorry, S and P both contain, sorry, not S, P and Q both contain the same C programming, but S contain hello C programming. Now the next function is if strcmp P and Q. So that means we are comparing these two strings P and Q. So you can see both are actually containing the same strings. C programming, both are same. So here this function will return 0 and output will be, this first condition is true, output will be matched. Okay, so the output, this matched will come in the output. First option is the correct for this. Okay, so I hope this is clear. How here we are performing arithmetic, that pointer arithmetic operation. So if we are adding 6, that means the size of 6 character will be added into the base address of S, and that after that strings will be actually read it, so that strings will be copied to this pointer P. Okay, so the address of uh, base address will become from C. So both string is now same, and you will get the matched answer. So now question number 14. Consider the C program given below. Okay, so this is structure based. So we have declared this struct score, and it have two field, roll number and marks. Okay, fine. Then this is the missing code. Okay, okay, main function. So just see the main function. What we are doing, we are declaring a variable struct score s1, and we are passing this two value 10001 and 80. So this 10001 will be passed inside the roll number, and 80 value will be passed inside the marks. And what we are doing, print score, and we are passing this address s1. Okay, so here you can see we are passing the address inside this function print score, and here we are initialize one pointer in the above function print score. We initialize the pointer, and that is actually reading the address of a structure. So I already discussed this. If you want to select all the correct implementation of function print score if the output of the above program is 10001 and 80. So that means we want to print the roll number and marks of that student s1. So we need to print both field of this pointer value p. But if we have the pointer of the structure, then we will not use the dot operator. Okay, so suppose if you are passing the structure variable, then we will use dot operator. Otherwise we have to use that arrow symbol. So here you can see what representation is correct. So the first option is contain p dot, so this is not correct because p is a pointer here. So another second option is direct roll number, so we cannot access the field without the structure variable directly. So this is also incorrect. Third option is contain p this dash greater than roll number and marks. Yeah, this is correct. Okay, and next is p roll number. Okay, so this is also not correct representation to access the field of structure. So option C is the correct representation to access. But here if we pass the only structure variable, then the option 1 will become true. If we are passing the structure variable, then we can access by the dot operator. Okay, next is question number 15. Consider the below C program. So this is enum base. So label here you can see A is not initialized, B is initialized by 5, C and D. And inside the code main function enum label where equal to D. So what is the value of D you have? So what is the value of A? We have not initialized, so by default it will initialize by 0. But B is initialized by 5, then the remaining value which are coming after this B will be incremented from the 5. So C will become 6, D will become 7. So here the output should be for this 7. Okay, so this is the output. So 7 is the correct answer for this. So in a union, how is memory allocated for its member? Each members get its own separate memory space of a fixed equal size. So this option is not correct because in union, each member is actually share the memory, common memory. Okay, so not separate memory. So this is first option is not true. And second option, allocated memory is shared among all members, and the memory size is equal to the size of the largest member. Yeah, this is statement is correct, which, as we have discussed. Allocate memory is shared among all member. Allocated memory is shared among all member, and the memory size is equal to the size of the smallest member. No, so this second part is actually is wrong. Okay, the size of the allocated memory is equal to the sum of the size of its members. So this is also not correct because we use the only one common memory which is actually allocated for the largest size member. So option 2 is only correct for the 16. Consider the following type diff declaration. So type diff int asterisk int ptr. What does int ptr represent in this declaration? So here, okay, so a pointer to an integer, an array of integer, an integer, okay, so an integer variable and constant variable. Okay, okay, so this int asterisk a point, yeah, okay, so we are actually declaring here int ptr, and this is a pointer actually. Okay, int asterisk, so int is representing here, this is a pointer for the integer elements. Okay, so int ptr is a pointer for the integer elements. So option A is correct. This is not an array, this is not an integer variable, this is actually a pointer, a constant integer. This is also not true. So first option is correct for this. Okay, next 18th. So how much the memory will be allocated for the ptr, assuming the program is being on running on the 64-bit architecture? Okay, so here int asterisk ptr, we are assigning this sort int asterisk. Okay, so this typecast we are using sort int asterisk. Okay, malloc size of int into 8. So in the 64-bit architecture, actually the size of integer actually a 4 byte, and 4 into 8 is 32 bytes. Okay, so 32 bytes is the correct, but 32 bytes and each byte contain the 8 bits. So if you multiply this 32 byte into 8, then this 256 bits is also correct. Okay, so both are the same size but the different representation. Okay, one is in bytes and another is in bits. So 8 into 4, simple. Next is you are given a 2D array ARC where R is represent the number of rows and C is represent the number of columns. Consider that array is implemented in column major representation in memory. Which of the following expression can replace Aij in the following step? Okay, so this is related to the memory representation. Okay, so let's just copy this question and discuss this. Okay, so column major implementation, what is this? Suppose we are just representing an array, how we can get the size? So I'm just taking one example. So like 3 by 4. Okay, so 3 is the row and this is the 4 is the column. So row 0, 1, 2 and 0, 1, 2, 3. Suppose we have some element like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is 3 by 4. Column major means if memory base address of this like 1000 for this first element. Okay, second element, this column wise means first column will come, then second column will come, then third column will come, then fourth column will come. Okay, so memory representation is look like this column wise. So this first value will be stored at this location, then 5 will store at this 1004 location, then 9 will store at this 1008 location. Okay, now this 2 will come at the next location. So like this 2 will come at the 1012 location, just like this. Okay, so memory is allocated like this column wise. Okay, now the question is, suppose if we want to calculate the address of like this a array of a and 2 and this 3, what is the address of array 2 3, or we can take 1 3 like. Okay, so for the clear representation, array of 1 and 3, so this is r, and this is sorry, this is I, and this is j, I and j. So how we can get this address? So that means for I, so we have column representation, our address is going like this. So that means first row and third column. Okay, so that means if you can see, this is the value 8, this row 8 value. So what is the address of this? How we can get the address of this directly? So which formula is actually correct for this? We are just verifying this. So how we can get this location by this formula? So you know, A00 is actually a address of the as a base address. So this is A is representing as a base address. Then plus how much size we need to add in this base address. So to reach this, so you have to complete. So this number of columns actually we are checking. So you can see our indexing is starting with 0 indexing. Okay, so that means this is the actually our fourth column, but index is 3. So that means we can directly use this value as how many columns we have completed before this, because we want to read this third index column value. That means till second index we have completed to reach this. Okay, so that we can directly use this. So 3 columns we have completed, so we can write like this. So number of j, not 1 second, 1 2. So first, yeah, so this is the location we have to add, but before this, so this is the first index. Okay, this is actually representing by I, and this is j. So we are just looking at the second row. Okay, so column wise, our memory is column wise. Okay, so what we can do, we can just write how many columns we have. So we have total j into, okay, and each columns, how many rows we have? 3. Okay, so j into number of rows, we can write like this. Okay, so that j is, for this example, j value is representing as a 3. So 3 into what is the r value? So because you can see this row, this column actually contain the number of rows, 3 elements. Okay, so we will just use 3 element size for this row, 3 for this, 3 for this. Okay, so because of that we are writing 3 into 3, total 9 element we have already covered before this location. Okay, so because of that we are writing this j into r. Okay, so 3 into 3 plus, so that means we have completed all these elements which are coming before this column, last columns. And after this location, so this location is representing 1 row. Okay, so this is I actually. So before that, what is the value we have? This only 0. So 1 element before that we have in the row. So this elements we need to identify. So we will write like this simple I. Okay, because I1 is representing as an index, but we have already completed 1 row before this 0th. So we can directly use I value. So we can directly write like this, a plus j into r plus I to reach at this position. Okay, so we can replace this I and j value like this. So a plus j is 3 into total number of r value is 3 plus 1. So that means, so 3 into 3, 9 and 10. So a plus 10. And what is the address of a is 100. So 100 plus 10 into 4, so 40. So 1040 is the address of this 8 value. So if you check this, so 1000 is the for this one value, then this is the for second, this is third. So if you write all the address, you will reach at this 1040, and that is for actually 8. So which option is correct for this? Because we are reading this value. So how? So you can see which is correct. So JR plus, we have already seen JR plus I. So JR plus I, you can see this last option we have. Okay. So JR plus I, and another option we don't have this J into R. So only this option actually contains this J plus R value. So option D is correct for this.
What does A asterisk mean here, sir?
Hmm?
Why is there A asterisk term?
A asterisk, actually we want to read the value
No, not asterisk to the whole term, but individual
inside this.
asterisk to A.
This asterisk you are talking about first.
Uh,
Asterisk
yes,
A,
sir.
asterisk A you are talking about.
Yes, sir.
Okay, so asterisk A. Yeah, this we have
It
to.
will dereference, na, sir, firstly, because A alone is the address of the first element. So why are we writing here asterisk A?
Yeah, looking correct, but I think dereferencing, actually we are all performing on the overall addresses. So let me just check this. Okay, so let's suppose we have integer array int, and a plus like 4. Actually, it not takes the argument. Like suppose if you write asterisk here. Oh, sorry, what is this? A? Just P actually. Right. A. Which of the following expression can replace Aij in the following snippet? Okay, so Aij. Yeah, this stick is not looking correct. Let me copy this completely. This is inside the two-dimensional array actually. Okay, so let's declare the two-dimensional array. Oh, this is because of the two-dimensional array. Actually, each column is also actually contain the 1 second. That's represent as a two-dimensional array. Okay, 3 by 3. P. So it is returning correct. Yeah, so this asterisk should not be there. It is not looking correct. Okay, so I'll check this. Okay, and update accordingly. So because we are performing this base address plus j into r. So if this is in column wise representation, so after that we are just referencing it. So this asterisk a should not be there. Okay, so maybe this is incorrect. Okay, but the remaining formula is basically j into r plus I is correct. Only this asterisk part before a should not be there. Okay, I'll also check this. So this is actually written, and later we will update inside this mock. Okay. Otherwise, the formula way is correct. So how we can calculate the
Sir,
formula?
it's
This
asterisk A. So A is defining the 2D array. It's referencing 2D array. So we are in the code we are trying to using pointer.
no. So
But
here,
it's not explicitly written here.
yeah, here it is only
It
mentioned.
could
We have
be.
the here we have the array only a. So this is not defined that this is actually declared by the dynamic memory allocation like this. So this is not a pointer of pointer like this. So this is only simple two-dimensional array. So when we have just
Maybe it
checked it,
would have tried to do it with second
Why we are using
two
pointer
degree
P?
pointers.
sorry,
Why we are using a pointer P here in the code?
here,
Yes.
okay, this is for the address representation because we are using the pointer arithmetic na, in this expression. We are using pointer arithmetic. Okay, so for
Okay.
pointer arithmetic, we have to take pointer value. So because of that, we are taking the pointer for which where we are storing this ARR. But actually, the by default the representation this representation is happening in the row measure form, not column measure form. Okay, but here actually we are checking this. If suppose if we are just writing this asterisk here, so actually it is giving error. Okay, so this
So what if
asterisk.
we use asterisk ARR?
Okay, you are saying this asterisk here. That is actually same. Okay.
I'm saying this.
But asterisk ARR, uh,
Asterisk ARR is referencing the number one, array location 0, comma 0.
no, but then it is not correct, na. So actually, what we are finding out the that 1 second. This operation is actually happen on the elements, but we are finding
Yes.
out like this ARR, and suppose we want to find out the element of 1 and 2. Okay, so like this. So corresponding, what is the pointer arithmetic operation for this? So this is the first index. So that means this row
It will show
and
5,
this six output. So first output should become six. You can
6,
see
6.
six. But then how we can write this as a pointer arithmetic form? So that we are trying to
So
here. Okay. So here what happening actually? It is taking the first value, this value 1, and that integer value we are adding 1. Okay, so 1 plus 4, it will become 5.
so
So
we
this
need a
is,
pointer and increment it, and
hmm.
then we need to print the value from the array.
So here what we can do, so this is row measure implementation. So suppose we can declare like this. So suppose if our integer int I equal to uh, that I equal to 1 and int j equal to 2. Okay, and we are writing here this I and j. Okay, and if we write this formula like, so what is the address of that location, so that we will write like I into that j plus, sorry, not into j, what is the size of this 3 plus j. Okay, and that if we write like this pointer p not p, 6 6, you can see we are getting 6 6 correct value. And if you're writing this asterisk, then this is the incorrect representation. Okay, so this asterisk should not become actually. So this formula basically we used in the row measure form if our array is implemented in row measure. Okay, but in the question statement it is asking for the column measure. So I have just changed the formula, but we have to start address with like this. Okay, so p plus I into the number of columns, then j, in this manner. Okay, so this asterisk should not
Okay.
become, yeah, this asterisk should looking incorrect in this option. But still this is common for in everyone, but the remaining formula you can check, and the option D is correct according to that. Okay, if we ignore this asterisk, then option D is correct, otherwise no option is correct if you're considering this asterisk. So I'll update this in the mock, but option D is correct. And question number 20. Okay, so this is two-dimensional array representation. So ij, we are declaring the malloc row size. Okay, so this first actually representation for the rows, so that we are creating an array of pointers. Okay, so this is representing number of rows. After that, we are representing the memory allocation for each row. Okay, so each row value is actually pointing to the one memory block. And what question is asking, which of the following statement is true with respect to the above function? Okay, so the function allocate memory for 2D array at the time of compilation. So this is not correct because we are using this dynamic memory allocation. So this first option is definitely not correct. This is not happening on the compile time. This is running on the runtime. So the function dynamically allocate memory for 2D array. Yeah, so this option is correct because here we are allocating the memory dynamically. The function does not initialize the elements of the 2D array. Okay, so function does not initialize the elements of 2D array. And the last option, the function initialize all the elements of 2D array with G. Okay. Yeah, second function we are using this calloc. Okay, so first function is malloc allocation. Second function we are using calloc. So calloc by default initialize all the elements with 0. So because of that, option C is not correct. The function does not initialize the elements of 2D array. Here initialization is happening with the 0 value by this calloc function. Okay, so this option is not correct. The function initialize all the element by the 0 value. Yeah, this last option is correct due to this calloc function only. Okay, so option B and option D is correct here. So this is based on the 2D array by the pointer. Okay, so this which we have already discussed function. Okay, so this till 20 we have the questions till week 9. After that we have the 5 questions for week 10 and week 11. So that we will discuss on the Friday session. Okay, so okay, any query now? Anyone from any topic? Week 7, week 6, that week 7, 8, 9. So after also complete this mock. So I think today is the deadline for this. So 24 year night 12. So complete this mock also before the deadline. Okay. Any query? So that this question number 19 I'll check and update if this is correct. I'm not sure why this stick is mentioned in the option.
Sir,
Hmm?
week 7 practice assignment last question 15.
Week 7 practice assignment. Practice assignment.
So last question, 15. Sir, how the answer is 5.
Okay, so int main character 10 A B C D. Okay, so A question mark okay equal to /0. Check here. Okay, print A. If the output of the program is A comma B comma C, A comma B comma C, then the value at uh, question mark. Okay, okay. So what happening actually? The 1 second. Let me just copy this question also. Okay. So we have the one array A, and that we have total 10 size, but we have initialized the elements like this. So first character is A, second character is comma. Okay. Third character is B, then next is comma, and C, and the next character is comma, and then D. Okay, so 0 1 2 3 4 5 6, and after that we have not initialized, so all empty places are empty. So 7 8 9. So what happened if we initialize this A question mark as a null character? Okay, so null character, because our output is only this A comma B comma C. Okay, so that means our output is coming only till this character, this part.
Okay, sir.
So when we are printing this A strings, so it will so if we put this null
5.
character, okay, so that means
Sir,
at
5
this location,
uh,
so that
yes,
if this we
understood.
will update this by null character, and
Yes,
if
yes.
we print this A, so so it will read character from the first location, so A comma B comma C comma C, and then it will find out the null character, so that our printing will stop at this location. So this will just a representation of the end of the strings. So
Okay, sir.
only this A comma B comma C will print. Okay, so that means output should be 5.
Yes, sir.
Okay. Any other query?
So where can I find the recorded lectures like this?
On the YouTube, or you can also see in the today calendar. And YouTube playlist is also updated, so you can also check the YouTube playlist.
Okay, thank you, sir.
Yeah, all sessions recording are there. And this drive link actually I'll also share in the today session, so that contains the notes we don't have. Okay, any other query? Okay, if there is no query, then we can wind up the session. Okay, thanks everyone. Good night. Okay, we will discuss the remaining weeks on the Friday.
Thank you, sir.